All right, so now we're going to turn our attention to the second formula. The second formula just has one binary connective, the triple bar, or the biconditional. So we don't have to worry about the order of the connectives. We just do the triple bar here. We're going to look under Q for our truth value for Q. We're going to look under P for our truth value for P. And then we're going to use our rule for the triple bar, the biconditional. So you might want to stop the video, see if you can remember the rule for the triple bar, fill out that column, then start the video and compare what you got to what I do in the video. Okay, our rule for the triple bar says that a biconditional is true whenever the formulas that it connects have the same truth value. It's false when they have different truth values. So in that first row, P and Q are both true, so the biconditional will be true. In that second row, P is Q and true is false, so they have different truth values, so the biconditional will be false. The third row, P is false and Q is true. They have different truth value, so the biconditional is false. And then that last row, P is false and Q is false, so they have the same truth values, and so the biconditional will be true. That gives us our truth value for this formula every different way the world could be. Now let's go over to our next formula here. Our next formula has a tilde and a wedge. Just as before, the tilde goes first and then the wedge. So our order is going to be tilde and wedge. Our tilde here modifies Q. So we're going to look under Q, use our for the tilde, and under the tilde, fill out the truth values for tilde Q using our rule. So again, you might want to stop the video, remind yourself of that rule, fill out that column, then start the video and compare what you did to what I did. The rule for the tilde says that the truth value for the tilde is the opposite of whatever it is it negates. So in that first row, Q is true, tilde Q would be false. In the second row, Q is false, tilde Q is true. Third row, Q is true, tilde Q would be false. And in the fourth row, Q is false, tilde Q will be true. So that gives us our truth value for tilde Q. Our binary connective connects P and tilde Q. So we're going to look under that tilde, and we're going to look under the P. I want to use our rule here for the wedge, or the disjunction. So again, you might want to stop the video, see if you can remember the rule for the wedge, fill out the truth table under that connective, and then start the video and compare what you did to what I do. The rule for the wedge, or the disjunction, says that a disjunction can only be made false if each of the disjuncts is false. So in this first row, tilde Q is false, but tilde P is true. So at least one of them is true, so the wedge, or the disjunction, will be true. The second row, P is true, tilde Q is true, so they're both true. So again, the disjunction, the wedge, will be true. The third row, P is false, tilde Q is false. So this is the one case where a wedge or disjunction will be false. And then that last row, P is false, tilde Q is true. And so there's at least one disjunct that's true, and the disjunction will also be true. So now we've filled out our formula for our truth table, rather, for this formula. Its truth value under that last connective, the main connective, is the truth value for that formula every different way that the world could be. Finally, we've got our last formula, and our last formula has just one connective, and that connective is the horseshoe. So you might want to stop the video, remind yourself what the rule is for the horseshoe, try and fill out the truth table body under that horseshoe for the truth value for that formula, and start the video and compare what you did to what I did. Our rule for the horseshoe is a rule for the conditional. and it says the only way to make a conditional statement false is if the antecedent, the left hand of the conditional, the open end, is true, and the consequent, the right hand, the closed side of the conditional, is false. So on that first row, antecedent is true, consequent is true, hence our conditional statement is true. On the second row, the antecedent is true, the consequent is false. That's the only way to make a conditional statement false, and so our truth value is false. On the third row, antecedent is false, consequent is true. Whenever the antecedent is false, the conditional statement is false. Or true, sorry. Whenever the antecedent is false, the conditional statement is true, and so when the consequent is false but the antecedent is false in that last row, then the conditional statement is true. So now we filled out our truth table for all four formulas. In our next video, we're going to want to look at reading off results from this truth table. Specifically, we're going to look at how to decide what kind of sentence any of these individual sentences are.